Hello class, this is Case Study 3 Part 1, which has the title, Can We Feed the World with Organic Food Alone? So before we get started, I want to start out this lecture with a thought question, and that thought question is about something called a genetically modified organism, which is abbreviated GMO. I'm wondering what you might think about genetics and genetically modified organisms. Do you think they could be classified as organic based upon what you know about the word organic? Now that we've thought about that, let's define what organic means in the context of food. And the United States has a program called the USDA Organic Certification. And this organic program is defined as the following. Organic production is a production system that is managed to respond to site-specific conditions by integrating cultural, biological, and mechanical practices that foster the cycling of resources, promote ecological balance, and conserve biodiversity. So when food is produced organically, the system does not impact the land or the people or the community in a negative way. So what does organic really mean in the context of food? Well, for crop farms where we're growing produce and other types of plants, it takes 3 years with no application of prohibited chemicals such as synthetic fertilizers, pesticides, or genetically modified organisms before you can harvest your first organic crop. And as long as you maintain that field for 3 years, after that you would be eligible for the USDA organic certification. Now for livestock operations, so for those operations that grow cows and pigs and sheep and chickens, you have to 100% feed those animals organic food, and you have to use organic management practices, which includes a very specific way that you handle things like antibiotics and other types of chemicals that you might give those animals if they get sick. And then lastly, for processing operations, which are those factories that process food, you have to have no contamination with non-organic products. So because this is a case study based course, our case study this time around is going to look at if we could feed the world with organic food alone. Some of you might have some ideas for what organic food is. Often when people think about organic food, they think about very expensive food, right? Organic foods can be more expensive than their conventional products in some cases. And so we really need to consider not only the cost, but also the economic, social, and environmental implications that would come from having a world without pesticides in our food system. So as a poll to get us started, what do you think? Yes, we can feed the world, or there's no way we can feed the world with organic food alone? Or perhaps you're somewhere in the middle. So the first section of this case study is on the human population. Let's see how feeding this growing human population can cause some big problems. Now, the human population is expected to grow quite substantially over the next few hundred years. And so that definitely is something to take into consideration when we are thinking about if we can feed the world without the use of pesticides. One question you might ask yourself is, well, what is the carrying capacity of the Earth? That is to say, how many humans can our Earth support before we start to see a global collapse? And it's really about the factors that influence this carrying capacity, such as quality of life. For the entire world to live like U.S. citizens live and Americans live, it would use up the resources of our Earth very rapidly. Here's a multiple choice question for you, just to get us thinking about numbers. The carrying capacity of the Earth is around, would you guess it's 2.5 billion, 7 billion, 10 billion, 20 billion, or 40 billion? What do you think? At what point would the global ecosystem collapse? Well, that number really we don't know. So that's kind of a thought-provoking question, because time will tell as we start to feed these growing human populations. But what I would say is it's not necessarily about space. The 7 billion people on our planet today, now we're getting closer to 8 billion people, they could all fit in a relatively small area if we just put their bodies shoulder to shoulder. But it's about the resources that are needed to support those people, and it takes huge amounts of land to grow all of the food that these people need. So to help us understand how the world population is expected to change, we need to consider population dynamics. The general study of population changes is referred to as population dynamics, and it is influenced by abundance of humans, birth rates, death rates, growth rates, and age structure. Now, how rapidly a population changes actually depends on growth rate, and growth rate is a very simple calculation that is simply birth rate minus death rate for a given population. Scientists estimate the present human population, which is to say the abundance of humans on our population. The U.S. population is well over 300 million, and the U.S. world population is on its way to 8 billion people. That is a lot of mouths to feed. In recent years, namely over the last couple hundred years, we've really been experiencing dramatic exponential growth in the human population. And this is largely due to access to resources. All around the world, people are living longer, they have access to more medicine and food, and because of that, our global populations have been in a steep increase overall. However, this human population growth isn't the same in all regions. For example, if we look at this graph, it shows us the number of people versus time. And accelerated growth definitely occurs in both developing and the developed regions of our world, but it's definitely increasing much quicker in the developing regions, and that's because developing regions are just that. They're developing. They don't have access to the same technology and services that the rest of us have in the developed parts of the world. So where is most of the world's population found? Well, in recent years, most of the world's population is found in Asia, and the rest of the majority is found in Africa. We have a substantial number in Europe, in Latin America, and the United States and Oceania as well. What about the United States? Well, our current U.S. growth rate is around 0.5%, but we do see it starting to slow down. People are simply not having children at such a young age anymore. You know, the times are changing. People are waiting until they get their career started. They're in college for longer times. And so we believe in 2040 to 2050, we will probably mark the slowest growth rate in recorded history in the United States. So now let's talk about age structure, because age structure is a key component of understanding population dynamics. So this shows us several age structure diagrams, which is the proportion of any population at each age. And you can see there's different age classes. We go from very young to middle years to old as we work up in the levels of these figures. Now, Nigeria is a country that has very fast growth. United States is slowing down, and Germany is more or less neutral. And these age structure diagrams are indicating that less developed countries such as Nigeria have a much higher percentage of young people than highly developed countries do. As a result, less developed countries are projected to have a greater population growth than highly developed countries. Now, if the majority of the population is under or at the age of reproduction, then deaths will easily be outnumbered by births in that population. Next up, let's consider this critical thinking question. How many people can our planet support in the first place? And to understand the implications of a human carrying capacity, we really need to think about the quality of life that we humans are willing to accept. Now, in the United States, we are seeing a slowing down of our growth rate, but we still have a lot of mouths to feed, and the American lifestyle is one of excess and consumption. We eat a lot of food, and a lot of that is processed food, so that can really impact how our food systems are maintained and created. A lot of our food nowadays is produced not at family-run businesses and family farms, but instead at huge commercial agricultural operations. And the reason for that, we don't have family-run farms anymore because they can't make enough money. Now that's changing, particularly in California. We have a lot of access to agriculture around the world because of our very mild seasonal conditions. And it is possible to have very affordable family-run farm products right at your table. But in other places in the United States and in the world, this is less possible. I highly recommend, if you have a chance, to watch the feature-length film called Food Inc., because it does a great job of talking about the agricultural system. So in the next part of this lecture, we're going to start discussing health problems. What are some different health issues that people face with food around the world? Not only food, but also agricultural systems. To understand this, we must look at these health problems and think about how humans have been using the food and the land for so many decades. In exploring this question, if we can produce enough food for the world now and for the future, let's try to think about this in the context of organic versus conventional agriculture. Let's consider whether, regardless of what system we use, could we feasibly feed the world now? Could we feed the world 50 years from now? Could we feed the world 100 years from now? Do we have enough food? Well, right now in our world, there are at least 25 nations and a third of our total population that is considered undernourished. Then we could ask ourselves, why don't these people have access to food? It seems like it would be a basic human right. So here are some of the current health issues that are facing people surrounding food. Undernourishment means that humans don't get enough total calories. Malnourishment, on the other hand, means you're not getting enough of the correct calories. For example, you might be eating lots of carbohydrates, but you're not getting enough protein, because protein can be very expensive to have access to. Another problem in the world is not just hunger, but it's foodborne illness. Sometimes inefficient food production systems can make people really sick. Finally, in other places of the world, health issues surrounding food are obesity and cardiovascular disease. When people have access to too much bad types of food, then people can get very unhealthy. They get the wrong types of calories, and then they can get a bunch of health problems as a result. Some humans are undernourished because they simply cannot access food. And this can be a problem that can be solved by simply increasing local food production. But because of corrupt governments and for other issues such as political turmoil, it can be really hard for some people to maintain a food system. So we're trying to feed almost 8 billion bellies around the world. And we know that there are high rates of both undernourishment and malnourishment. So would it be better to feed people cheaper crops like corn? Or are people hungry simply because food is too expensive? These are questions that we will explore as we do some different online assignments. Now, in some places in the world, we are eating way too much corn. Even though corn is a cheap crop, it can be linked to different health problems. Especially in processed foods, there is tons of high fructose corn syrup. And overconsumption of high fructose corn syrup is strongly linked to diabetes. So it's really important to limit that food, but when you go to the grocery store, if you don't read the label, you wouldn't even know that all of this high fructose corn syrup is in your food. Another thing to consider is animal agriculture. And you might have heard that cows are either fed corn or they eat grass in a pasture. And some scientists believe that corn-fed cows are less healthy. That's largely because cows don't typically eat corn. Cows would just be grazing animals, but we give them corn because it's cheap and readily available, and it fattens them up quickly. However, sometimes when we analyze that meat, corn-fed meat versus grass-fed meat, we can see a difference in the types of vitamins and a difference in the types of fatty acids that we find in those products. However, corn-fed meat is a lot cheaper than grass-fed meat, and we have a lot of mouths to feed. So, large-scale farming is not relatively new. It's been going on for many, many decades. And along with large-scale farming comes issues with food poisoning, because when we put so many animals in a relatively small space, it leads to rampant bacterial growth. And if that food isn't processed properly, it can lead to health problems for humans. Not to mention the animal rights issues that goes along with some types of large-scale farming. Foodborne illness can also include exposure to things such as pesticides and heavy metals. Remember, we talked about exposure to heavy metals when we did our case study on the San Francisco Bay and the mercury in the bay. Well, we can also get exposed to chemicals when we eat foods that are grown in conventional ways. Foodborne illness is actually more common than you think. Often people have diarrhea and they think they have the flu or something like that, but in reality it might just be foodborne illness. There are billions of cases every year, and they're largely connected with improper food processing and improper food handling. So, in this first part of Case Study 3, we've looked at a growing human population and some of the health problems that this growing human population faces. In our next lecture, we're going to continue putting together the pieces of this puzzle in our exploration of if we can feed human populations with organic versus conventional food. So far, we've said that organic food practices are typically better for humans and the environment, but it doesn't solve the problem of the cost. We know that conventional is cheaper and more readily available. By the end of this lecture, I hope you will have a better understanding of all of the different factors that go into our food system. All right, that's it for part 1. Please email me with any questions, and thank you so much for listening.